Your call. All right, guys. So this is going to be on page 147. Yes. All right. So our essential understanding for this section is you can use logarithms to solve exponential equations, and you can use exponents to solve logarithmic equations. Okay, that's ultimately what we're coming to at the end of this section. However, we're going to start off with just exponential equations. Okay, so to solve exponential equations with the same base. Okay, key word here is that they have the same base. Okay, in case you didn't understand why it was capitalized, that's our key word. So first off, you have to write the base in prime factored form, which means that if we were to break this number down, what would be its prime factored form? Okay, so that each side of the equal sign have the same base. Okay, then we're going to set the exponents equal to each other and use inverse operations to solve for x. Okay, when we're using inverse operations to solve, that's SADMAP. And you're doing PEMDAS backwards. And then you're going to check yourself. Check yourself is, of course, it's an optional step. But when you ask me if you got something right, I'm going to say, did you check yourself? Okay, so just be mindful of that. So these are our 3 simple steps. Write in base form, same base form, make the exponents equal to each other, and then check our work. Okay. So step 1, we're going to start off hard with a fraction. All right, we're going to come out of the gate strong. We have 1/16 equals 64 to the 4x minus 3. Okay, 1/16 is a fraction. To change a fraction into a non-fraction, remember that means that you have to make the power of it negative. So you need a negative exponent. So this is going to be written as 16 to the -1. That's how you undo the appearance of a fraction. So now we have 16 to the -1 equals 64 to the 4x minus 3. All right. It says that you need to have the same base. So when you were talking about the same base and it says factored form, if you're going to factor this, think about 16. If I was to break down 16, that would be 4 and 4, right? 2 and 2. So 16 equals 2 to the 4. Agreed? All right. Or I could do 64. So 64 breaks down to be 8 and 8, which breaks down to be 4 and 2, which breaks down to be 2, 2, 2, 2, right? How many 2s do I have? 1, 2, 3, 4, 5, 6. So 64 is 2 to the 6. That's what it says. That's what it means by being in prime factored form. How do we feel about that? About your factor trees? Okay. So that's what we're going to do. So 16 is now going to become 2 to the 4. And you're going to protect what was already there by putting in parentheses. So we're putting -1 in parentheses. Equals 64 now becomes what? 2 to the 6. And we're going to protect what was already there, which was 4x minus 3. That is what step 1 wants you to do. What are your questions about step 1? No questions about step 1? All right, step 2, now that your bases are the same, all you're doing is taking your exponents and setting them equal to each other. So if you take 4 to the -1, set it equal to 6 times 4x minus 3. Is that just not a basic algebra problem for you to solve for x? It is, right? So what is step 1 to start solving for x? We're going to multiply stuff, right? So we're going to multiply. 4 times -1 is -4. 6 times 4 is 24. 6 times -3 is -18. What do I need to do to get x by itself now? Move 18. So I'm going to add 18 to both sides. And that gives me, what's -4 plus 18? 14. 14 equals 24x. What's the last thing to do? So x equals 14 over 24, which reduces to 7/12. Good job. So my answer is 7/12. All right, so let's zoom in on the algebra. So all we did for the algebra again was we multiply, which meant we distribute. After that, then it just became a two-step linear problem, right? We add, then we divide. So we added 18, and then we divided by 24. We got 14 over 24, which reduced to 7/12. Okay, so that's step 2. Because once your basis is the same, step 2 says all you have to do is focus on the exponents. Okay. All right, so step 3 is where you check yourself. That's where you're like, ooh, I'm not sure if I really did this right, right? So step 3 is you go back to the original problem. And where X is, you plug it in to see if it makes a true statement. So if I plug in 7/12, do I get a true statement? Okay. And we're just going to use Desmos Scientific to check ourselves. So I'm going to go to Desmos Scientific really quick. And I'm going to put in 64 to the, what was it? 4 times 7/12 minus 3. Ooh, minus 3. No, I need the 3 to be at the top, bro. Minus, no, stay up there. Why won't my 3 stay? Okay, let's try that again. Times. It won't stay up there. 4 times 7/12 minus 3. I did it. It did it itself. I'm just going to do it in parts. I'm doing it in parts. So we have 4 7/12 minus 3. Bam. Going to turn that into a fraction by just clicking the little fraction bar. Gives me negative 2/3. So now I'm going to do 64 to the negative 2/3. Hit enter. Turn it into a fraction. Is that what I needed to be? Yes, it equals 1/16. So what does that tell me? I did it correct. Yay. You're a genius. All right. So that's what it means to check yourself. All right. So let's do this again. So on this one, we have 4 and 8. So step 1 is to make the same base. So if I was to break down 4, that becomes simply what? 2 squared, right? If I was to break down 8, that becomes 2 to the 3rd, correct? So now we have 4. I'm sorry, not 4. 2 to the 2nd. So 4 is 2 squared, and we protect what was already there, which was 4x equals, and what is 8? 2 to the 3rd. So that's step 1, making sure that they already have the same base. Do they have the same base? Yeah. So step 2 is all you have to do is take the exponents and set them equal to each other. Now, what do you need to do to get x by itself? Multiply. So we have divide by what? Divide by what? 8. So what does x equal? 3 over 8. I can't reduce it anymore, right? So again, checking myself. So to check yourself, you would plug in 4 3/8, which is going to give me 4 to the 12/8. So I'm going to go to my handy dandy calculator and see if 4 to the 12/8 gives me 8. So I'm gonna try to go back to my calculator, open it, and we put in 4 to the 12/8, hit enter. Do we get 8? Yay, we did it. Yes. So funny that you asked this, because someone asked this last class. I don't know what your career is going to be in your life, but the main purpose of math, especially in high school, is to help develop your brain skills. So it's literally its purpose is to help you with problem solving, pattern recognition, and just general cognitive understanding to help develop your frontal lobe. So it's to make you smarter overall. Yes. Oh, it does. I've witnessed it. All right, so before we leave, I would like for you to do this one. Here's yours. Here's yours. I believe in you. All right, so let's check and see how you did. So 125, what did that factor down to be? 5 to the 3rd, good. And gives you 9x minus 2 equals, what did 25 factor down to be? 5 squared. Right? So now you have the same base. So step 2 is you're taking your exponents and setting them equal to each other. So you have 3 times 9x minus 2 equals 2. You're going to distribute. You're going to distribute. So we get 27x minus 6 equals 2. And then we're going to add 6. And we get 27 equals, x equals 8. And then we divide by 27. So you should have gotten x equals 8 over 27. And then always do what if you don't believe in yourself? Check it. All right, please stay in your seat until I dismiss you.